Hello, and welcome to what I hope is the first in a series of CAB presentations for the September full board meeting for 2020. We're recording this on September 8th, but you'll have the ability to watch this whenever you like. Today, we're going to have the first presentation by Pat Suggs on the salt waste processing facility. I wanted to introduce it very quickly, just so that you know why Pat's presenting and not Pam Marks. I know that you're all used to Pam presenting. She's been doing a great job as the Federal Project Director for the past several years now. But today marks a big event. It's a big transition. Pam was talking to you about construction. Now we're transitioning to operations, and that's what Pat's going to be talking to you about today. Pat, are you ready?
Thank you, James. As James said, I'm Patricia Suggs. Most people call me Pat, and I work in the assistant manager for waste disposition. I work in the programs division, and I am the SWPF program manager. Pam Marks is a hard act to follow, as James noted, and there's many people in the assistant manager for waste disposition organization that are picking up and doing their various responsibilities with respect to SWPF transition to operation. So just for your convenience, the acronym list, it helps you, it's the government way to have acronyms. And so this page will assist you in determining what an acronym stands for. Our agenda today is to talk about completion of the project for the salt waste processing facility and to discuss the transition from a project to operations. The phase that we are about to enter is called hot commissioning, and we'll talk about the objective of hot commissioning. We'll discuss the startup plan that covers the period of hot commissioning, and I'll describe some elements that are in the startup plan. And then we'll talk about increasing feed from non-radioactive conditions to normal radioactivity levels. And then lastly, we'll summarize and talk about the path forward. So this is the photo of the salt waste processing facility. You may have seen this before from Pam's presentations. There's the office building, and this is the actual processing building itself. And just to go back over some historical information, this is the mission challenge for salt waste processing facility. Of the 35.5 million gallons that we have stored in our tank farms, just under 3 gallons belongs to the sludge component. And it's very thick mixture, sort of like natural peanut butter. And then the majority of that waste is about 33 million gallons of either a very rich supernatant liquor high in sodium hydroxide or crystallized salt cake. And that crystallized salt cake will be dissolved with water before it can be fed into the SWPF processing processes. So these volumes will increase over time as the salt cake is dissolved and the salt batches are mixed up. But that's quite a hefty mission for the salt waste processing facility. We're looking forward to getting started. And this is our system chart just to show you the basic layout. You'll see here our tank farm system in a hypothetical large tank. We have 43 active tanks. Again, just under 3 million gallons of sludge out of that 35 million gallons as stored. And something that's new on this particular chart, the ARP MCU facilities have been laid up now. The transfer lines have been realigned to be connected to the salt waste processing facility. So now ARP and MCU have a dotted line, and the salt waste processing facility has a solid line. So we'll be using those transfer lines soon. And then also we have a small scale ion exchange system called Ticker Tank Closure Cesium Removal, which has been operating and processing a relatively small amount of volume so far, around 300,000 gallons. Then just as a refresher, the radionuclides are removed from the waste at the salt waste processing facility, and they are sent to, that's a small volume out of the very large volume sent to SWPF. The radionuclides are transferred over to DWPF, where they're incorporated into the borosilicate glass that's put into the glass cans, and those cans are interim stored on site until there's a repository. And then the decontaminated salt solution, after the radionuclides are removed, is transferred to the saltstone facility here at the bottom. Okay. And much less than 1% of the radionuclides actually make it to saltstone. There it's treated with grout powders to become a non-hazardous solid waste form and placed in the saltstone disposal unit. We're very proud of the fact that we already cleaned and closed out 8 tanks. So we used to have 51 active tanks. Now it's down to 43. So just a recap there of our overall system. And on to the salt waste processing facility project. So on August the 17th, DOE headquarters approved critical decision 4 and an authorization to operate for the salt waste processing facility, the project, and it authorized hot or radioactive operations to begin at the facility. So that's a significant step from being a project toward the transition, the segue into an operational process. CD4 makes that official and recognized at the headquarters level. That approval comes 5 months ahead of the baseline CD4 completion date of January the 31st, 2021. And just to show that headquarters does in fact, much of the world recognizes this, but EM1 of headquarters stated this is a considerable achievement for EM's cleanup program, and it will drive significant progress in treating the tank waste, SRS, over the next decade. So that's the senior advisor to EM, to the Undersecretary of Science. His name is Ike White, William Ike White. And so we'd just like to congratulate Pam Marks and the entire project team, and this is both the DOE team and the contractors team, for a significant accomplishment for successfully achieving this significant milestone. So operations, the operational and contract oversight will now be performed in the assistant manager for waste disposition. That's Jim Folk. You've probably seen Jim Folk at the CAB meetings, and his support team. That includes me and many others. Parsons Corporation, who designed and built this first-of-a-kind facility, they'll perform the hot commissioning over an approximate 3-month period. They will be followed by 1 year of operations, and it is managed by Frank Shepard and team, and we'd like to congratulate Parsons also for making it to CD4. So if you see them, please mention it. I'm sure they'd like to enjoy the accomplishment. So SWPF remains on track to start normal operations later this year, following the completion of hot commissioning. The objective of hot commissioning is, following completion of the extensive cold commissioning tests, which have already been performed, and the contractor operational readiness test, and the DOE operational readiness reviews, and the receipt of the DOE authorization to operate on August the 17th, now we can begin the hot commissioning phase once we've reached readiness to start that phase. The objective of the hot commissioning phase is to confirm operability of equipment viability of procedures, and performance and knowledge of the operators during the radiological operations. The transition from cold operations to full radioactive hot operations will be a deliberate, carefully managed process to ensure the safety of personnel and the facility. And it's based upon this SWPF startup plan. So the SWPF startup plan establishes additional control site to be implemented during the hot commissioning phase. And that's the critical period as the plant begins deliberate operations and introduces radiological hazards for the very first time. Many of the processes inside the facility have been tested with non-radioactive stimulants that resemble the waste, but now we are actually going to embark upon raising the radionuclide limit from 0, or content from 0, on toward normal. So the startup plan, it describes specifically the management and facility activities necessary to achieve normal operations, and it has certain emphasis areas: the management and technical oversight, the equipment operability, and the procedure viability, the operator knowledge and performance, and final management review and authorization. These things, of course, have to be checked and rechecked for all the shifts, all the shift managers. So it's 100% coverage for the personnel of SWPF. So some examples of equipment operability. I've mentioned that they have already performed high capacity processing and with non-radiological stimulants, but they'll do that as part of the hot commissioning process. Only they'll be using waste that, or they'll be using material which is has had radioactive content introduced. So one of the things that they'll start checking immediately upon the first small transfer of real waste into the facility is they'll take shielding measurements all around the facility. And each time the radioactive content increases a little bit, they'll repeat all of that. So they're checking to ensure that the radioactive exposure is consistent with the design criteria for operators in the facility. The second thing they'll do is check the processing rates, that they can sustain and support the high processing rates. They've done that again at non-radioactive operations, but now they'll be doing it with radioactive material. And then lastly, similar to the shielding, they'll start taking emissions measurements as they step up in radioactive content, to ensure that the airborne emissions meet the regulatory criteria and the permit requirements. So that's equipment operability. Secondly, on procedure viability, an area of interest now is the between facility transfers. Those have been, you'll see a photo there, that is the simulator transfers between facilities, and there's 4 primary transfer routes. There's the feed transfers from the tank farm to SWPF. There are 2 transfers, one solid, one liquid, from SWPF to DWPF with radionuclides. And then lastly, there's the decontaminated salt solution transfers from SWPF to Saltstone. So during the hot commissioning phase, they'll be actually, in fact, for the very first transfer, they'll be doing these transfers for real from both the sending facility and the receiving facility. And they'll be confirming that those procedures are all consistent with what we would expect to perform. So it's going beyond the non-radioactive stimulants. So hot commissioning is a series of incremental batches in which the radioactivity content progressively increased. It starts with about 10% of normal, then it's increased to 20% of normal, and so on. So I mentioned the capacity test. That's 12 batches at full strength, approximately 0.6 curies per gallon. That's the strength in salt batch 1. During the 12 batches, they'll continue to confirm that the shielding is performing as expected, and to demonstrate the process rates at normal conditions. And then after all the contractual tests have been completed, reviewed, and approved, the plant manager will release SWPF for unrestricted hot operations, at which time 1 year of hot operations commences. Now, during this period, DOE has its own oversight plan so that we are monitoring each of the contractors' outcomes, and we have 24/7 coverage during their startup plan. So where are we now? Well, we should begin hot commissioning in September. Current schedules estimate 3 months duration to accomplish hot commissioning. But it's important to remember that deliberate startup plan execution is more important than schedule. So after that, following that, if DOE concurs that it's time to complete the hot commissioning phase, then we'll begin the first 12 months of operations. We forecast that will be in December, or begin in December. And SWPF is expected to process 4 to 6 million gallons during the first 12 months of operations. Are there any questions?